Okay, the law of detachment is if P implies, remember this is red, implies Q is true. So if P then Q is true, and we know that P, the hypothesis, is true, then Q must be true too. It seems like it is pretty straightforward, but actually it's kind of tricky and people misuse this law of logic all the time. So I'll show you with examples. So if it is a circle, then it is red. So it is a circle is our P, it is red is our Q. So if we know that it's a circle, which I'm only counting these, then it is red. So are all these circles red? Yes, they are, because if it is a circle, then it is red. So if we know the object is a circle, then we can conclude it's red. So what do we know if the object is red? Well, we can't claim anything. Okay, so it doesn't go backwards. So if you know that P implies Q is true, so if it is a circle, then it's red. Then if we know that it's a circle, then it's red. So if P is true, Q is true. But we can't go backwards. We can't say if it is red, then it's a circle. Because that's not true in our pictures. This is red and it's not a circle. We only know that if it is a circle, it's red, and if we're giving a circle, then it's got to be red. But we can't say the backward is true. That's how the law of detachment can be confusing. Here's an example with numbers. So if x is greater than 12, then x is greater than 10. So the law of detachment says if we know x is greater than 12 is true, then we know that x is greater than 10. So let's try it. If x is greater than 12, so this number, this number, this number, then x is greater than 10. That's true. That makes sense. But what if we know that q is true? That we know that x is greater than 10. So here are numbers that are greater than 10. Just because these numbers are greater than 10, just because q is true, does not mean that p is true. So what do we know if x is greater than 10 is true? We know nothing. We can't conclude anything. This is law of detachment. If P implies Q is true, and we know that P is true, then that means Q is true. But it doesn't go the other way. If we know that P implies Q is true, we can't say that Q is true, so P is true. This example fits it. If x is greater than 12, then x is greater than 10. We know that's true. So we know that if x is greater than 12, then these numbers are greater than 10. But we can't say that if x is greater than 10, then x is greater than 12. It doesn't work that way.